We're going to look at evaluating expressions with exponents here, and a little recap. We should know exponent. What we're really talking about is repeated factorization here. So, for example, 3 to the 4th, that's the same thing as saying 3 times 3 times 3 times 3. Okay. Now, when we talk about 3 to the 4th, this is an exponential expression. And all we're doing here is just evaluating these things. And we've touched on exponents a little bit earlier, but we're going to be getting more in depth here. So let's look at a couple examples where we're going to be evaluating expressions and seeing what they mean. The first one, let's look at 2 cubed. Well, it's the same as saying 2 times 2 times 2, which would be 8. If we want to evaluate 2 cubed, 2 times 2 is 4 times 2 is 8. Let's look at what happens when we have negative numbers again. So let's say we have negative 3 squared. Well, remember, an exponent is only tied to the base that it's immediately attached to. And in this case, the negative sign is not part of the base, only the 3 is. So what this means is we're looking at 3 times 3, which is 9, but we have to place that negative in front of it, so we're looking at negative 9. Now conversely, if we look at something like negative 3 in parentheses squared, then what this means is really this exponent is now tied to the base, which is everything in the parentheses. So if we think about that now, we're looking at negative 3 times negative 3. We know a negative times a negative is a positive, so there we get 9. So this is a very important thing to remember when we're evaluating expressions with exponents is if we have a negative sign, we need to be careful whether or not it's part of the base. And what about fractions? We could have something like 2/3 squared. And we can rewrite this. We're squaring everything that's in here. We're taking everything in this parentheses to the second power, which means we could separate numerator and denominator. We can go 2 squared over 3 squared. And sometimes that's just easier for us to say, or see, not say. So 2 squared we know is 4, 3 squared is 9, so 2/3 squared is 4/9. This is, again, just evaluating the expressions. The last one let's look at a decimal. Let's say we have 0.4 squared. Well, we know 4 times 4 is 16, but if we think about this, if we go back to our little elementary school days and we multiply 0.4 times 0.4, we know it's 16. But remember, we add up all digits, values, whatever we have to the right of all decimal places in our factors. And we have 2 here, so we have to move the decimal point 2 places to the left. So 0.4 4/10 squared is 0.16, or 1600ths squared. And something else to touch on here, another example, that's not the last one, I guess. Whether the base is a number or a variable, it doesn't change how we work at this. So say we have something like 2x squared. Well, that's really saying 2 times x squared. So we look at this and we say, okay, what about when x is equal to 3? Well, we'd be saying 2 times 3 squared. Well, that's 2 times 9 is equal to 18. So if we're evaluating in that sense with a variable with an exponent, we can still work that when we have a value for the exponent that we can replace it with. Let's look at one more little example here. Let's say we have 12 over x to the 3rd. And we'll say what happens when x is equal to 2. Well, in this case, we're having 12 over 2 cubed. We should know that's 8. So we can have 12 over 8, which is 1 1/2. We can leave it at 12/8. We can take it down to 3/2, whatever we'd like to do there. So this is evaluating exponents. I don't think they should be terribly difficult at this point. Next one we'll look at product and power rule of exponents. So have a good day. Bye.